All right, this video is going to look at Gosset's T, and specifically we're going to look at the assumptions and conditions that are associated with it. Now, Gosset, who developed the T model, he realized that in order for the math to work out correctly on this, certain assumptions were necessary and they had to be met. So we actually have two different types of assumptions. The first one is called the independence assumption. Now on this, the condition that has to be met under this is the randomization condition. And then it says this condition is satisfied if the data arise from a random sample or a suitable randomized experiment. Okay, so one assumption and condition that we have to have is that we have to have a random sample or as random as we can get. The second one is called the normal population assumption. And what we have with this is called the nearly normal condition. The data have to come from a distribution that is unimodal and symmetric. So unimodal, think about that, it has to have one mode, okay? We can only have one mode to our data, and it has to be symmetric, which means we basically want it to look like a normal model. Now, if you have a very large sample, some skewness is acceptable, but if the sample size is small, it should follow a normal model pretty closely. So what we're going to look at is an example, and basically we're just going to look at these assumptions and conditions and see if they are met. So this problem says researchers purchased whole farm salmon from 51 farms in 8 regions in 6 countries. The histogram shows the concentration of the insecticide Mirid in 150 farmed salmon. So it says that we have 150 total salmon. These came from 51 farms in 8 regions in 6 countries, and we're testing the concentration of an insecticide in these fish. So the first question says, are the assumptions and conditions for inference satisfied? Now we have 2 assumptions that we have to look at. First one, the independence assumption. And what this means is it has to be a random sample. So in this one, it's not truly random, but the experiment, I think in this case, is suitable because we've got quite a large range where these fish came from. They came from 51 different farms, 8 different regions, and 6 countries. So because it was spread out, I think it's pretty safe to say that the samples are independent from one another, and it's likely that this does represent a pretty good sample of salmon that are farmed worldwide. So I would say we've met the independence assumption. Now the nearly normal condition, we want to know if we've met that. And for that, you pretty much always have to have a histogram to look at that, okay? That's the easiest way that you're going to be able to see this. First of all, it makes it really easy to tell if your data is unimodal. And that, again, means it has only one mode. Now, these bars all represent the different concentrations of insecticide and how many fish had that concentration. So you can see that we have one mode. We have one bar that shows our maximum value. So the data is unimodal. Now on this one, we want to also look and see, does it resemble a symmetric or a normal model? Now this one, not quite so much. It's got a little bit of skewness to it. But because we have a sample size of 150, because we have such a large N value, this one, it'll be acceptable for a little bit of skewness. So we can also say that it met the nearly normal condition. Now, because both of these were met, because the independence assumption and the nearly normal condition were met, what does that mean? Well, that just simply means this is an okay set of data for us to use for inference about farm-raised salmon. And that's basically all there is to the assumptions and conditions.